Hi, I'm Meeeke, and I'm on a mission to show you exactly how to build amazing games in Scratch. Today's theme is the viral Suika watermelon game. We aren't just building a simple version, we are going from a quick beginner build all the way to a professional list-based physics engine. I've got my digital assistant ready to help with the heavy lifting, so let's dive into the code. Take it away.
Thanks, Meeeke. Let's look at the beginner version. This build uses a simple object-oriented design where every fruit is an independent clone. To set it up, we have our fruits sprite with 4 default costumes ordered from smallest to largest. We use a global score variable and a local clone variable to keep track of everything. The dropper and cloning mechanism is one of the most important parts of this game because it allows the player to aim and drop multiple fruits over time. Here is how this logic works. We use a forever loop that tracks your mouse position. When you click, it triggers the clone generation, and we use the isClone flag to tell the game that this new fruit is now part of the physics world. Gravity is another crucial element because it brings the game to life by pulling the fruits down. Here is how it's implemented. In the clone script, we have a simple loop that repeats until the fruit hits an edge or another fruit, constantly decreasing its Y position. This makes the clones fall smoothly to the floor. Merging is the core mechanic of Suika because it's how players score points and progress. In this beginner version, we use a clever trick to detect collisions. First, the fruit momentarily increases its size by 20. While it's enlarged, it checks if it's hitting the specific color of another fruit. If a hit is detected, it updates the score, grows into the next fruit size, and tells the other fruit to delete itself. This size probing technique is a great way to make merging feel responsive without complex math. Let's see how it works. Our beginner game is fully functional. You can aim, drop, and merge fruits just like the real game. However, notice the limitations here. The most obvious is rigid stacking. Because we are using basic sensing, the fruits just pile up in straight lines. Another issue is inconsistent merging. Since the code isn't perfectly sequenced, you'll sometimes see 3 fruits merge into a single larger one at the same time instead of just 2. To fix these behaviors and get professional physics, we need to go advanced. Let's upgrade to professional physics. We are moving to a data-driven list-based engine where a single loop processes all the math. For this version, we've upgraded to 11 high-quality custom SVGs and replaced our simple variables with these 4 global lists to track every fruit's data in real time. To keep the game stable, we clear all our data lists whenever the game restarts. Instead of the old cloning system, we now have a spawner that records the exact X and Y coordinates into our lists the moment you click. This data-driven approach is much more powerful for complex physics. Merging in the advanced version is handled by precise mathematics. This logic handles fruit progression and scoring by checking every pair of fruits on the screen. It calculates the exact distance between their centers. If this distance is less than the sum of their sizes, and they share the same level, the engine merges them. It deletes one entry and upgrades the other to the next fruit level instantly. When fruits overlap but aren't the same level, we use collision resolution to create that smooth squeezing effect. Instead of just stopping, the engine calculates exactly how much they are overlapping. It then mathematically pushes their coordinates apart in our lists. This constant pushing is what allows fruits to slide past each other and react to pressure when the box gets crowded. Finally, the main tick loop is critical because it ensures all these physics calculations happen instantly. By using a custom block set to run without screen refresh, Scratch calculates all the gravity, merging, and pushing in a single frame. This prevents the fruits from glitching or falling through the floor even during heavy action. Let's see how it works. Just look at the difference. The fruits now squeeze and react to each other perfectly, giving the game a much more professional feel. We went from a simple clone prototype to a robust, math-driven engine. If you want to make your project even more authentic, you could try adding cute faces to the fruit costumes or implementing game over logic for when the fruits reach the top of the box. These small details really bring the game to life. I'll hand it back to Meeeke to wrap up.
Thanks for coding with me today. Don't forget to like, subscribe, and let me know in the comments what we should build next. Happy coding!